Hi Pre-Calculus Honors, so these are notes 5.5. Go ahead and take a second to read our objectives for this lesson. Okay, so we are going to be talking about the law of sines. So here's the law of sines. Let's go ahead and do a little proof for the law of sines. So let's say that we have a triangle. And don't forget that when you have angle A, we use an uppercase letter, and the side opposite would be lowercase a. So opposite of angle C would be side C, and opposite angle B would be side B. So if we go ahead and drop an altitude, we're going to find the height. Let's call that height 1. So we know that the sine of A is H1 over C, if I'm looking at the right triangle that we created there. So H1 is C sine A. And we know that the sine of C, if I'm looking at this right triangle here, on this side, there we go, we know that, let's see here, sine of C is H1 over A in that yellow right triangle. So now we know, since H1 equals C sine A and A sine C, we know that C sine A is equal to A sine C. And if you divide both sides of the equation by AC, we know that sine A, the C cancels out. Sine A over A is equal to sine C over C. But we're not done. So we're going to take the same triangle this time, let's go ahead and drop an altitude. We'll call that H2. So now we're looking at a right triangle. Let's see, I'll make it yellow to help your eyes a little bit. There we go. So in the yellow triangle, you could say that the sine of angle B is equal to H2 over A. And then over here, if I'm thinking of angle A, the sine of A is opposite over hypotenuse, so that would be H2 over B. So we know that A sine B must be equal to B sine A, and divide both sides of the equation by AB. So now we could put this all together here, and we know that since sine of A over A equals sine of C over C, sine of A over A also equals sine of B over B, we know that sine angle A over side A is equal to sine angle B over side B is equal to sine angle C over sine C. So now that we know that the law of sines, we just proved it, right? We could, when do we use the law of sines? So let's start, first of all, thinking about when I might use law of sines. If I have a side angle side triangle, for example, so that means that I'm given the measure of two sides. So for example, let's say that this side is 10 and this side is 12, and the included angle was also given. Let's just say that's 30 degrees. So let's call this maybe A, B, D. Okay, so if you think about it, the law of sines for this situation would be sine of 30 divided by side A, sine of B divided by the side opposite B, which would be angle B, which would be side B, and then sine of D over side opposite angle D, which would be 10. So do you see how this would not work? Because if I use these two ratios together, notice we'd have two unknowns. If I use these two ratios together, I would have two unknowns. If I use these two together, I have two unknowns. So notice it's not helpful for side angle side triangle. We are actually going to use the law of sines for angle side angle, angle angle side, and then this one is a little bit scandalous, the angle side side triangle. So let's start with number 3 here. So what we're going to do is we're going to go ahead and label our triangle. So if B is 48 degrees, side B has to be opposite angle B, and then here's C, A is 30 degrees, and here's A. So go ahead and pause the video for a minute and think about how you might start this problem. Okay, so notice that we have all of the angles. When you add up the three interior angles of a triangle, they add up to 180. So we know that angle C is 100 degrees. So you could say the sine of 100 degrees divided by C is equal to the sine of 48 degrees divided by 10 is equal to the sine of 32 degrees divided by A. So now we have to pick we need a proportion. We need to pick two ratios that have only one unknown. So we could start with the sine of 32 over A equals the sine of 48 over 10 if you like. We could cross multiply and then divide because we want to get the A. We want to isolate the A. So if you divide 10 sine 32 by sine of 48 degrees, go ahead and pause the video, make sure you're in degree mode, and you can find A. Hopefully you typed this into your calculator and got 7.13. Now let's use sine of 48 degrees over 10 is equal to sine of 100 degrees over C. Go ahead and solve for C. So you have 13.25. Okay, let's do another triangle. So go ahead and pause the video and see if you could solve the triangle for number 4 using the law of sines. Don't forget that angle M is opposite side M, angle A is opposite side A, angle D is opposite side D, and we know that the three interior angles of a triangle add to 180, so 180 minus 68 minus 32, we end up with 80 degrees. So now you use the law of sines, and A is 2.69 and D is 4.71. So we talked about, I don't know if you realize this, but the first example and the second example we had for number 3, we had an angle, side, and for number 4 we had an angle, side, angle. Because notice that for number 4, 5 was included in between the two angles, and for number 3 we had an angle included in between the angle and the side. So the last one that we didn't talk about was ASS. So we're going to talk about that right now. That's actually the ambiguous case. So here's a little GeoGebra. So first of all, let's say that we have a triangle and we're given, I need to get my pen here. So we're given an ASS situation. So I actually, I know it spells a bad word, but I actually like to write it as ASS because I think that helps us because we're going to set it up the same way every single time. So I recommend putting your angle here, your given angle, and then one side here and one side here. So see how it says ASS, if you think of it this way, ASS. So that's why, again, I think it's easier if you just write it like that. So we just, with this little GeoGebra here, we could pick out for the angle. The given angle was 30 degrees. I just made that up, and then I made B 10. Okay, so I started off and I made A kind of small. So notice what would happen. If I try and make a triangle, do you see how it's too short? So that's why this is called the ambiguous case, because if you're given an angle and two sides, and one of the sides is included in this way, notice that it's possible that you could have no triangles at all. Let's write that down. So no triangle at all. 0 triangles is possible. Now, what if I made this A a little bit longer? Okay, it's a little bit touchy here. All right, so notice, and I purposely picked 30 degrees because the sine of 30 is 1/2, right? So I knew that we could figure out that if this is a right triangle, that I could say the sine of 30 degrees is opposite over hypotenuse, right? So anyway, so that's why I picked that, because I wanted to be able to show you that watch how this happens. So I know that this is a right triangle. And maybe that was a little confusing the way I wrote that, but like I said, let's say we don't know this is 5 and I call this h. The sine of 30 is opposite over hypotenuse, so we would know that the height has to be 5. So that's how I'm convinced that this is a right triangle right now. And notice that this side A was just long enough to make it. So notice that if the A was too short, we would have 0 triangles. If the A was just long enough, we would have 1 triangle. But watch what happens next. What would happen if I made A really large? Like, I don't know. There you go. Do you see how we could definitely make a triangle? Let's say I make it even bigger. Let's exaggerate. So do you see how we could definitely make another triangle? So I also get a triangle, 1 triangle, not only if that height, if that side was exactly equal to the height of the triangle, but also the altitude of the triangle, but also take a look here, you also get 1 triangle if A is really long. Now here's where it gets very interesting. Let's say, remember the height was 5. Let's say that I make A less than 10, but bigger than 5. I don't know. So like, there you go. So do you see how I could make a triangle like this? But I also could drag this side over here and make a triangle like this. So do you see how this is unclear? Because if this opposite's the side opposite the given angle, if it's longer than the height yet smaller than that side B, notice you have 2 possible triangles. So let's just summarize. Okay, we'll summarize. So you had 0 triangles. Let's just call this the height right here. When A was less than the height. And remember, the height was 10 sine 30, right? Okay, so we had 1 triangle when A was equal to the height, or when A was greater than or equal to 10, because this other side over here was 10. So let's just go ahead and do that. So again, if we made A 10, try to make it exactly 10, notice that you get a triangle, but if I tried to make a triangle over here, I couldn't make another triangle over here. So that's 1 triangle. Or if it was a bit larger, notice I'm certainly not going to make another triangle. So 1 triangle. All right. And then we had 2 possible triangles when we made this A that perfect length, that it was longer than the height, yet smaller than that other side of 10. So do you see how there was a triangle like this, or a triangle like this, an obtuse triangle or an acute triangle? So we had 2 triangles if A was greater than the height, yet less than that other side. I always call that, it's like right in between. It's a tweener. It's right in between the length of the height and the other side. Okay, so let's go back to, we'll quit out of this. Let's go back to our notes and we'll do some examples. So here are the steps. We're going to label the triangle. We're going to do the test and find the height to see how many triangles we have, and then we're going to solve. Okay, so here goes. Here's the first example. Let's see, do I probably have a pen? Okay, so let's say we have a triangle. Now, we always want to set it up the same way, and I want, if it's a given angle, I want to put it right there. So I'm going to put A here. Opposite A is side A. Now, you have to decide where to put the M. Notice that I would put angle M here because, again, I want it to be ASS. ASS. I want the given angle, then the given side, then the other given side. In that order. Okay? So now we have, let's see, the other side was T. Okay, so we notice that 5 is less than 6. Now, if 5 was 6 or more, we would say, oh, 1 triangle, move on. But we notice that 5 is less than 6, so we don't know what's going on. If 5 is too small, you have no triangles. If 5 is equal to the height, you have 1 triangle. But if 5 is, it's a tweener, it's right in between. It's larger than the height, yet smaller than 6, you have 2 triangles. So we need to find the height. So we would say the sine of 30 is opposite of hypotenuse. So H is 6 sine 30, which is 3. So notice 5 is, it's right in between. It's the A is larger than 3, yet smaller than the other side. So we have two triangles, and the other triangle, if you remember, looks like this. It's obtuse. So we know that this side is still 6, this side is still 5, this angle is still 30. However, notice I like to call this T1 and T2. These lengths, these side lengths, are definitely going to be a different length, and these angles M1 and M2 will be different values. Okay, another thing we should talk about now that we have two triangles. So remember that this side was that perfect length that we could put it here or here and make two different triangles. Notice that these, since this is the same side, these sides are congruent. So if sides, then angles. So notice that these two angles add up to 180, they're supplementary. So that means that these two angles must be supplementary. Okay, so let's go back to the GeoGebra for a minute and show that. Okay, so for example, notice I picked something that we definitely had two triangles. So if I put this same side, if I move this same side over here, notice it's the same length, so they're congruent. So if sides, then angles. So these angles are supplementary. So that means that these angles are supplementary. Okay, so let's go back to our example now. So we know that these two angles will be supplementary. So we're going to use the law of sines right now to find the measure of M1 and M2. So notice they're not the same measure. So we'll use law of sines. So the sine of 30 degrees over 5 is equal to the sine of M1 over 6. Go ahead and use your calculator in degree mode. After you go ahead and do 6 sine 30 divided by 5, you'll have to do inverse sine. Okay, so you should have gotten 36.87. But now we know that these two angles are supplementary, so subtract from 180, and you get 143.13 for M2. Then we know that the three angles of a triangle add up to 180, so subtract from 180, and you get 6.87 for this angle over here, and you get 113.13 for this angle T over here. So now we're going to do the law of sines two more times, one time to find T1 and another time to find T2. So we could say the sine of 113.13 over T1 is equal to the sine of 30 over 5, using law of sines in the first triangle. Solve for T1, and you get 9.20. Over here in the second triangle, the sine of 6.87 degrees over T2 equals the sine of 30 over 5. Again, you could cross multiply. Grab your calculator in degree mode, and you should get, for T2, 1.20. And that does make sense because notice this side looks much smaller than this side. Okay, great job, everybody. Let's summarize. So now we're going to use letters to summarize. So if I draw a triangle, and I will call this angle B because that's given, and remember we're always going to do ASS, 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 right? So start here. Angle B is given, side B is given, and I'm going to put the angle A here because again, I want it to be the given side, to be the included side. So now if we drop an altitude and call it H, we know in this right triangle right here that the sine of B is opposite hypotenuse. So the height is A sine B. So zero triangles, then you would have zero triangles if side B was too short. So if B is less than the height, which was A sine B, you would have zero triangles. One triangle would be if the B was equal to the height. So if B is equal to A sine B, or if B was greater than or equal to A. Remember, we talked about how B is really long. And then 2 triangles would be if the side B is greater than the height. There you go. If we'd have 0 triangles if side B is less than the height, which was A sine B. 1 triangle if B was greater than or equal to A, or if B was equal to A sine B. And 2 triangles if it's right in between, if side B was greater than the height, which was A sine B, and less than A. So notice this is, we have given information, and went ASS, right? And we just used the law of sines. Okay, the next thing we're going to do is we're going to try and draw a picture to describe the situation. So go ahead and pause the video and use what we've learned about bearing to draw the picture. So you traveled at a bearing of 40 degrees to reach the exotic port. Then you had a bearing of 106 degrees. So due south would have been 180. So that's how I know that this angle is 20. Alternate interior are congruent, so I know that this angle is 40. So this angle must be 60. And then we were told about the 15 and the 14. So notice you have to kind of tilt your head a little bit, but you have an ASS triangle. So if we redraw that and put this angle right here, the exotic port, right? So notice it's 60, 15, 14. So 14 is less than 15, so we would have to find the height to see how many triangles we have. So go ahead and pause the video and find the height. Now the height was 12.99, and 14 is larger than the height, yet smaller than the other side. So we have 2 triangles. So I drew the second triangle here. So the first thing we have to do is use the law of sines to find h, because again, these angles are supplementary. You use the law of sines in that first triangle. If the sine of h over 15 is the sine of 60 over 14, and you get 68.11. Now if you find the supplement, 181 minus 68.11, that would give you this angle right here. So it's 111.89. Now we add up all the angles in the triangle to find this angle right here, because you could add them up and subtract 180. This is 8.11, and this angle right here is 51.89. Okay, so the last thing we have to do is find these 2 missing sides. So we know that the sine of 51.89 over x1 is equal to the sine of 60 over 14. So x1 is 12.72 miles. Go ahead and pause the video and find x2. Okay, so that means that this side right here that we're trying to find has 2 possible values, because again, this is the ambiguous case. So there are 2 possible values since there were 2 triangles. It could be actually 2.28 miles or 12.72 miles. They also want the bearing, so we would have to find angle theta, which we already did. We know that that was either 68.11 or 111.89. So as far as the bearing goes, it could either be 68.11 plus this 40 degrees, 108.11, or it could be the 111.89 plus 40 degrees, which would be 151.89. So 2 different answers for the bearing and 2 different answers for the distance, because again, there were 2 possible triangles. So the other 2 questions we will have for homework. But let's go ahead and start them now, just so that we would, later on, maybe it would help you if you had a couple examples. So for the first thing we're doing is we're thinking about this Ferris wheel, right? And we're talking about how there are 16 evenly spaced cars. So I know that there must be 22.5 degrees in between each car. So this would be 22.5. And again, this distance right here would be 15.5 feet, because that's what they told us. Think of the spokes of a wheel, right? So we know that 180 minus 22.5 divided by 2, grab your calculator, you should get 78.75. So go ahead and pause the video. How could you use law of sines right now to find x? Go ahead and pause the video and give it a try. Hopefully you got 39.7 feet, because you could say the sine of 78.75 over x is the sine of 22.5 over 15.5. Go ahead and pause the video and draw a picture for number 43. We did. So first of all, we're trying to find the height of a flagpole. Now notice I kind of exaggerate a little bit, but I knew that this larger angle, this X, right, I kind of drew the picture, you'd have to be a little bit closer if you had to tilt your head more to look up to the top of the flagpole. All right, so first of all, in the great big triangle, you could say that the sine of 140 over 600, let's call this A, is equal to the sine of 19 degrees over A. If you solve for A, you should get 303.96. But what I want you to do now, that's not what they asked us for. They want the height of the pole. So how would you find the height of the pole? Pause the video and give it a try. So see how you could say the sine of 21 using the right triangle. So you could actually use SOHCAHTOA. I'm using this right triangle right here. The sine of 21 degrees is H over A. And we already knew A, so we could find the height of the flagpole. Nice job, everybody.